Welcome to the latest episode of AI Frontiers, exploring AI's cutting edge, breakthroughs in intelligence. This synthesis covers 59 papers from December 9, 2025, delving into innovations in computer science artificial intelligence. Imagine a tidal wave of 59 papers reshaping AI's future. Themes such as safety, language models, and robotics are unpacked here. Technical insights are blended with real-world impacts for all audiences. The journey proceeds from field basics to future directions and key papers. Engagement is maintained through a narrative connecting AI's power to everyday life. Computer science artificial intelligence is dedicated to building machines that mimic human smarts. Focus is placed on learning from data, reasoning through puzzles, perceiving the world via sensors, and making decisions in uncertain environments. This field powers transformative technologies, from self-driving cars dodging pedestrians to algorithms predicting disease outbreaks. Efficiency is driven in healthcare through personalized treatments, in agriculture through optimized crop yields, and in security through spotting cyber threats. However, ethical debates arise on ensuring AI does not amplify biases or go rogue in critical systems. A dominant theme emerges in AI safety and alignment, addressing how powerful systems can be made reliable and ethical. Information theoretic limits are extended in papers like Vassilev's, applying Gödel's theorems to demonstrate why perfect AI robustness is a Sisyphean endeavor. Divides between safety and ethics communities are mapped, with proposals for governance frameworks such as AI Tips 2.0 to operationalize risks. These efforts highlight a philosophical quest to formalize intelligence itself. Language models and their applications form another key theme, with large language models adapted for diverse tasks. Region-specific farming advice is generated, reducing hallucinations via geospatial retrieval. Scientific information is extracted, and conspiratorial narratives on social media are modeled. Toolkits for conversational agents simulate user interactions, showcasing versatility. Retrieval-augmented generation enhances accuracy by fetching relevant data on the fly. Robotics and embodied AI emphasize agents navigating physical worlds, often multimodally. Urban environments are synthesized in SimWorld-Robotics for robot testing. Protein simulations are conducted in DynaMate for drug discovery, bridging virtual and real chaos. Graph neural networks model relationships, capturing interconnections for better clustering and explainability. Overlaps occur with multi-agent systems for collaboration. Agentic and multi-agent systems involve AI acting autonomously or in teams. Frameworks are developed for molecular discovery and multi-agent intelligence in oncology decisions. Reinforcement learning trains agents via rewards, fostering adaptability in dynamic environments. Progress is pushed toward foundation models with native multi-agent intelligence. Key findings from these papers include AgriRegion's geospatial-aware retrieval, which cuts large language model hallucinations by 10 to 20%, delivering tailored farming advice that boosts yields. Theoretical limits on AI safety are proven by extending Gödel's incompleteness, indicating fundamental blind spots. In cybersecurity, AI agent scaffolds outperform most human experts at vulnerability detection, though with higher false positives. TRIO combines large language models, reinforcement learning, and tree search to improve drug properties by 8 to 12% and diversity fourfold. Cross-modal benchmarks reveal multimodal large language models' modality gap, struggling with conflicting text and images. Or methodologies recur across these papers. Large language models power text generation, planning, and inference, with strengths in generalizing from vast data, but limitations in hallucinations and compute demands, often mitigated by fine-tuning or external tools. Retrieval-augmented generation fetches relevant data on the fly, enhancing accuracy in niche domains while depending on data quality. Graph neural networks model relationships, excelling in interconnections but scaling poorly on large graphs. Reinforcement learning trains via rewards, effective for dynamic environments though requiring massive data. Monte Carlo tree search simulates decision paths, balancing exploration and exploitation for optimization, despite high computational needs. The first spotlight falls on Apostol Vassilev's paper, Robust AI Security and Alignment, a Sisyphean Endeavor, from December 10, 2025. Gödel's incompleteness theorem is extended to AI via information theory, modeling AI as logical structures to derive bounds on entropy and information loss, revealing inherent uncertainties. Redundancies like multi-model checks or human oversight are suggested. Findings show AI cannot be fully robust due to undecidability, with theorems quantifying blind spots. This reframes AI ethics toward managing flaws, influencing policy for adaptive safeguards. Next, Fanuel and colleagues' AgriRegion, region-aware retrieval for high-fidelity agricultural advice, also from December 10th, addresses large language model hallucinations in agriculture. A retrieval-augmented generation framework incorporates geospatial twists with a knowledge base from local sources, re-ranking by region metadata and geo-constraints. The AgriRegion eval benchmark tests across 160 questions. Hallucinations drop by 10 to 20% with higher trust scores. This empowers global farmers and models domain adaptations for other fields. Finally, Junkai and teams toward closed-loop molecular discovery via language model, property alignment, and strategic search from December 9th integrates fragment-based large language models, reinforcement learning for rewards, and Monte Carlo tree search for exploration. Designs iterate in protein pockets, tested on benchmarks. Improvements include 7.85% better affinity, 11.10% drug likeness, 12.05% accessibility, and fourfold diversity. This accelerates drug discovery and pioneers multi-objective agents in scientific domains. Future directions point to unified safety ethics frameworks building on theoretical limits for resilient AI. Hybrid human-AI systems are expected to scale for robotics and agents. Hallucinations, compute costs, biases, and ethical divides are to be addressed through interdisciplinary work with psychology and policy. Exploration of AI's role in causality and ethical evolution is anticipated, focusing on efficient, responsible integration across industries. This synthesis was created using AI tools, including GPT models, with TTS synthesis for audio narration and image generation for visuals. Review was conducted by a human expert. Potential oversights are acknowledged, with all references provided for further exploration. Subscribe to the AI Frontiers YouTube channel for more AI insights. The channel, titled AI Frontiers, dives deep into the latest breakthroughs in artificial intelligence research. Updates on cutting-edge papers and narratives are provided regularly. Subscription and notifications are encouraged to stay informed. In this podcast, the latest breakthroughs in computer science and AI are brought straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified to keep listeners ahead. Whether a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If this episode was enjoyed, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by the arXiv preprint server.